All right, guys, welcome back. Let's get into the summary now. So we're going to take the data that we've collected and some of the things that we are set to calculate and take that into the summary. The first thing I'm going to talk about is how we finish filling out that table. And the next thing that I'm going to talk about is how we apply that information that we have to what we've been asked in the summary. Okay, so let's go ahead and share so you can see what I'm talking about. And let's go back. So we were working with this piece of paper and it had the data in it and it had some calculations that I'd done on it. That's great. Okay, everything that we do from here is not data that we collect in the lab or part of the pre-lab. It's calculations that we're going to be doing after the fact based on questions that we've been asked. And you say, well, okay, where are these questions exactly? They come from this document. So this is the pre-lab and summary. Now, it says to construct the following data tables in your lab notebook. See below. And then we're supposed to put in the final concentration of the Fe solution, the volume of that solution that we added, because we calculated the molarity of that. I didn't give you the answer, but we calculated the molarity of that. We then have to know how much KSCN we added and how much HNO3 we added, and then that percent transmittance, which was actually given to us right here. We have that data. In the second table, we need to know the volume of the iron, the volume of the KSCN, the volume of the HNO3, the percent transmittance, and then we need to calculate the concentration of the iron and the SCN in each of the solutions that we made. So the first thing we need to do is collect all the information from the lab manual about what we actually did. So I'm going to go back to the lab manual and I'm going to look to see where that information is. So we've got two tables full of data that we're probably going to have to use. And actually the first one that I want to talk about is this one here, table 3, preparation of standard solutions. Let's see if I can zoom in a little bit. And so preparation of standard solutions. And you'll see that beaker 1 through 5 has different amounts of that Fe3+, but we have the same amount of the KSCN. Now, table 3 in the lab manual corresponds to table 1 in the pre-lab / summary. So I'm going to go ahead and I needed a little light. So I'm going to go ahead and start filling in this paperwork that I have. I'm going to fill in how much of that FeSCN I used in each one. So this is 5 milliliters according to what's in that table. The next one down is 4. And I don't actually need the milliliters because that column is labeled with milliliters. So I don't actually need that. I need 5, I need 4. This one is 3. This is 2. And this one is 1. And I'm trying to make that as legible as possible. Still kind of messy, but that's the best I can do with my handwriting. Now the next column, it says in here is the 2 molar KSCN. Well, that's this column right here in the table. So I'm going to put in, and it's 5 milliliters for all of them. So I'm going to fill in the 5 milliliters all the way down in this table. Notice I skipped that one in the middle, okay? We're then going to look at the HNO3. Well, in order for me to do that, I'm going to need to slide over a little bit. And I see that this last column is the 0.05 molar HNO3, which is exactly what this column right here says. So this is 15 milliliters. The next one is 16 milliliters. Then we have 17 milliliters, 18 milliliters, and 19 milliliters. And I'm going to write total milliliters over here because what I see when I look at the data that I've put in here, these change, this does not, okay? So that implies to me that the volumes should be similar, right? So if I add 5 milliliters and 5 milliliters, that gives me 10, plus the 15, that's 25 milliliters in that first sample that I made. Then I have 4 milliliters plus 5 milliliters is 9 milliliters, plus the 16 is 25 milliliters. And in my head, I've already done the math, and I know that the rest of these are 25 as well. But each time I do this, I make sure that that's actually 25 milliliters. And I know they don't line up perfectly, but with me and my handwriting, that works fine because I know that there are 5 of them and there are 5 lines, so that's the way it should be, okay? So I know that that's there. Now, the other thing that I'm supposed to calculate is the concentration of the iron in that solution. Okay, so let's talk about that. Now, how did I make that solution? I took 5 milliliters of the diluted iron that I made here. So this calculation that I did, that concentration is now the starting concentration for this next calculation, because I'm using this diluted solution to make the ones in this table. So that molarity for M1 here is equal to number 3. It's that same thing that I already calculated, okay? The volume for that is going to be based on this amount that's in the table. So this one is going to be 5.00 milliliters. My V2 is going to be the total volume for each of these solutions. And that is, again, 25 milliliters that I'm making out of all of these things. So my M2 is unknown. So again, I'm going to take an M2, M1, V1 over V2 is equal to the M1, which is the answer to number 3. I'm going to multiply that by 5 milliliters, because that's how much of it I used, and divide that by the 25 milliliters that is the total volume. And that answer right there is beaker number 1. Now I need to do the exact same calculation for beaker 2, beaker 3, beaker 4, and beaker 5. The M1 is always the same number. So it's that answer number 3 that we already calculated. That's what I use for every single one of these things, because I'm just using different amounts of that solution, not a different solution. So I am not calculating beaker 1 and then using that molarity to do the next one. That's not what I'm doing, okay? We're just using a different volume of that solution to do the next one. So this answer is for beaker 1. For beaker 2, we're going to be using M1 equals number 3, V1 equals 4 milliliters, V2 equals 25 milliliters, and M2 is equal to question mark. And we'll set up the exact same calculation for that, okay? So that's how that is going to look. All right, awesome. Now, let's talk about the next table, because the next table is a little bit different. So in the next table, we need to scroll down to the data that's for part 2. So let's scroll down and we start looking at, okay, we're going to do this. And they gave us a table here of what goes in those beakers, right? So beakers 1 through 5. I have 1 mil of the iron, 1 mil of the KSCN, and 4 mils of the HNO3 in the first one. So because of the way my brain works, I'm going to do all of the FeNO3 first, then the KSCNs down, and then the HNO3s down. So my first one, I have 1 mil of the iron. I have the second one down is 2 mils, then 3 mils, and 4 mils, and the last one is 5 mils. Okay. If I look at the KSCN, it's exactly the same. So I want to make sure that that column looks exactly the same. So 1, 2, 3, 4, and 5. Now the HNO3 is different every time, okay? So I need to make sure that I have looked at that and I'm putting in those values. In the first beaker, the HNO3 is 4 mils. The next one, we use 3 mils, then 2 mils, then 1 mil, and then finally 0 in that last one, okay? Now, if I do the total out here, because I need to know what those volumes are to be able to do these calculations, right? That's my V2. I need to make sure that I know. So I have 4 mils plus 1 mil plus 1 mil is 6 milliliters for that first beaker that we're talking about. The second one, we have 2 plus 2 is 4 plus 3 is 7. And if you check the math on the rest of them, please do check the math. 6, 7, 8, 9, and 10. Now, I know that this is a typo, that the desire was to make it 10 milliliters for each of them, but that's not how this worked. So we need to make sure that we're working with the numbers that we were given and that we're actually prepared in the laboratory. This is what we do in the lab. Even though I, as an instructor, know that this was not what it was intended, this is what I have people do. Okay, so that is the information that goes there. Now, if you look at the Fe concentration here and the SCN concentration here, those are calculations. So right now, that's everything that I have in this table. I'm going to have to finish this table to turn in the pre-lab part. That's what the pre-lab part on this paperwork is for. But for now, I'm done. What I'm going to tell you is that inevitably, during the summary, when you're filling out the summary, they're going to ask you to calculate things that will go in this table. So let's take a look at the summary. The first thing that they ask me about, and I'm going to change over and do a different document here. I'm actually going to go to the summary. And here I have filled in this exactly the same way I did before. So the calculation for the initial concentration, this is number 3. This is the same calculation that we did previously. I just rewrote it. So that's number 3. And then I've filled in this table with all of the information that we have and the percent T's, okay? Now it says objective. And when I look at the lab manual, if I scroll all the way up, I know that there was an objective that was in here. And that's what I'm going to want to put in the summary in my own words. If I do that, I can see that this page number in the lab manual is page 13. So that's why you'll see that the objective says page 13 and in your own words, because you need to do it in your words. The next part is page 14. That's the reaction for this. So the next page, it shows the reaction. Okay, that Fe3 plus the SCN minus goes to FeSCN2 plus. The equilibrium expression is on page 15. It's equation 1.3. So the next page, 1.3, that's this expression right here. So we want to see the K equals FeSCN2 plus over Fe3 plus times SCN minus. So that's what's desired there. If I scroll down a little bit more, I see that transcribe the required calculations below. Show the calculation to obtain M of the dilute Fe3 plus solution from table 1. That's the calculation we already did to find number 3. Okay, so we just want to rewrite that here so that we can turn that in. Okay, that's all we've done there is to put that calculation so that it's viewable by the instructor so that I can see what you did. Okay, so that's the first page of that. Now we haven't finished filling in the tables yet. We'll get to that. When we go to the next page, we'll see we want to show the calculation for the Fe3 plus in beaker 1 for the same solution in 2. So where are we talking about? Show the calculation of Fe3 plus in beaker 1 for the sample solution, which is table 2. So this is the preparation of equilibrium solutions. I want to know what the iron concentration is in beaker 1. Now, that is the calculation that goes right here. So that first line where it says 1, we're looking for that number right there. And you'll see that it says B and that the SCN says C. That's because this is number B and this is number C. So I want to make sure that I'm calculating those and then putting them back into the table. What I have done is I've written that my M1 is the 0.002 molar. That's what's in the lab manual. So that's that molarity there. I know that in that first beaker, I'm using 1 milliliter. My total volume is 6 milliliters. And so my M2, the molarity, is going to be equal to 0.00200 times 1 divided by 6. That number is going to be the answer for B, which is then going to go back in that table. Okay, and I only explicitly have to show the first beaker. Okay, but I will need to do that calculation for all of these Fe's that are here. So 1 mil, 2 mils, 3 mils, 4 mils, and 5 mils. And those will all go into this table right here. Sorry, wrong one. No, right there. Okay, so that's how that will get filled out. Go awesome. C, this calculation, it says to show the calculation for the SCN minus in beaker 1 for the sample solution. Well, okay, that's awesome. So that's based on this table too. It's 1 milliliter, same volume as we used for the iron. concentrations are the same. So those two calculations should look exactly the same. And on my paper, they do. Okay. So the 0.00200 molar times 1 milliliter divided by 6 milliliters. And that gives me the answer to C, which then goes in here in C. And then we change those volumes of the SCN to fill in the rest of that part of the table. Okay. So that's that. Now, I get people who ask me, okay, well, what's the final concentration of Fe3 plus solution? Well, I calculated the molarity of the first solution, and that was question number 3 in the pre-lab, which I calculated here. I then calculated again right here in question number 4. From the answer for question number 4, I can also do, and I'm going to move it over here just so you can see, whatever that answer is for number 3, that's the new molarity that I'm going to be using to build the values in this table. Need to move that. So these final concentrations are going to come from that molarity. Now, how much of each of those did I use? Well, that was the information from this table, which we filled in already on the other page, but I don't want to have to keep flipping back and forth. So I used 5 mils for the first part. So if number 3 is M1, V1 is 5 mils, and V2 is the total that I made for that beaker. That's 25. So that's 25 mils. So M2, the value that I need to put in the table, is then going to be equal to the answer to number 3 times 5 milliliters divided by the total volume, which is 25 milliliters. And that is what I'm going to put in table 1 for the final concentration of Fe3 plus. Okay. And again, you'll do one of those for each beaker since the amount of Fe that I'm adding in each beaker is different. Okay. So that's what goes on for that. Now that does not have to be explicitly shown here. I just need values in this column right here. Okay. So all of these will be filled out based on the calculations that you've done. And you only explicitly have to show one of those calculations. And that's everything for that. The next thing it says is to create a calibration curve, absorbance versus Fe SCN2 plus concentration, using your data from part 1 and 2 of the lab. A spreadsheet on D2L has been provided to help you. Well, if I want to use that, I got to go find that spreadsheet, right? Let me pull up the spreadsheet. This is what you've been given. And so what I'm looking at here, you'll see you must fill in the highlighted cells for %T first. Then from the graph, you'll fill in D17, which is this thing right here, based on the line of your equation. Now, it should auto-populate. So this should, if I were to change this to 6, right, that should change everything. So that should be fine. Now, I'm going to undo that. A couple of things that you'll probably want to note. You need to fill in not only these yellow values, but you also need to verify that these calculations are correct, because they may or may not be. Now, while it is my goal to make sure that everything is there, it is your goal to make sure that the tools you've been provided are doing what they're supposed to be doing. Okay, so you're going to be asked during this summary, and I'll show you that. It says, for trial 1, use an ICE table to calculate the equilibrium constant for the observed reaction. You will use the initial concentrations of the reactants calculated in table 2 and the equilibrium concentration of the FeSCN2 plus from the completed graph and spreadsheet. This provides an example of the calculation completed by the spreadsheet. So what it's telling you is what you need to calculate, and that it's actually doing that for you here. So it does. You have your initial concentrations that you have to verify here, the percent transmittance here. It then calculates the absorbance as it does. So there's a conversion for those two things. Then it says, okay, that absorbance based on this slope is going to give me this value for, so that's the absorbance. That's going to be this value right here of 3.66 times 10 to the minus fifth as the concentration for that solution for FeSCN at equilibrium. If that's my FeSCN at equilibrium, then I also know that that's the value of X. So when I do my initial concentration of iron minus X, that's this calculation. Now, where exactly does all that come from? Let's go up and look in the lab manual where we talk about that, this right here. Okay, move this over. What we have right here is if they've set up an ice table, right? And so I have an initial concentration of Fe3 plus that they've listed as A, an initial concentration of the SCN minus, which they've listed as B. You can plug both of those in from the information from the lab. And your FeSCN2 plus is 0. We know that for every one of these FeSCNs I produce, the plus X, I have to consume an Fe3 plus and an SCN minus. So I have a minus X for Fe, a minus X for SCN minus, and a plus X for FeSCN2 plus. My equilibrium row is then going to be my initial minus the change. Actually, I just say it's the initial plus the change, because this is already negative, so I don't want to subtract it and then add it back. That's the math-wise, that doesn't work. So I just want to have this come together. So A minus X, B minus X, and this is X. Okay. So I'm going to plug that in. If I know what X is, I should be able to calculate what A minus X is and what B minus X is. And then I plug all of those values into equation 1.3, and that will allow me to calculate K. You need to show that for the first beaker, okay? Every single part of that. What X is equal to, therefore what the Fe3 plus is equal to, therefore what the SCN minus is equal to, and therefore how you set up the K and find that value. So that's what that's asking for. The other purpose of doing that is it's calculated these values for you, but that will verify the calculation that's done in the spreadsheet to make sure that it makes sense. And if it doesn't, we need to figure out where and why. Okay. Now, one of the things, well, we'll talk about that in a minute. So that should be everything that you need to calculate to be able to do your summary. Let me verify that that is true. I want to go look at my summary again. Oh, wrong one. Hold on, let me go over here. Oh, there we go. So that'll be the last calculation in the summary. So that is everything that is due for the summary. If you have any questions, comments, problems, concerns, anything about that, then let me know. I have done my best to tell you where everything will be so that you can do those calculations and how to do them so that you can get 100 points. Now, I don't care that you get the right answer. What I care is that you know how to manipulate that. It's far more important to me that you know what to do with those numbers than it is that you got the right one. So if a mathematical error happens, you're going to lose a point, but you're not going to lose all the points if you set it up right. Okay, because it's more important to me that the setup is correct. That's why my grading policy says no work, no grade, because I can't tell what you're doing if I don't see your work. So that's everything for the summary. I'm going to take a break here and set up for the post lab. So that's the last thing we have to talk about. And then I will get all of this posted so that then we can talk about something else. And I think what I'm going to do is start with the chemical equilibrium lecture. Then I'll do the acid base that we should have done today. And then I'll go back and do the review from 110, which is the first lecture. That way we don't get any further behind and we get caught. All right. So that's everything I've got for now. I'm going to stop sharing and I'm going to stop recording.